All right, hello everyone. Welcome. I hope everybody had a nice spring break. Hope you were able to actually take a break and relax and are ready to get through the last part of the semester. We've got about, what is it, 6 weeks left or something like that until classes are over, and it'll be finals week. So kind of in the home stretch now. Of course, this week we have our next exam. So this is going to be an exam review session today. I'm going to spend a few minutes just going over logistics, make sure everybody understands that part of it, and then hopefully we'll do some practice problems, some coding for the rest of the time. The good news is that the logistics for exam 2 are basically the same as exam 1. So the exam is this Thursday from 6:30 to 8:30 p.m. It should be in the same room that you took it last time. So if you remember what room you went to last time, that should be the same room. I did not change the room assignments, so everybody should report to the same room that they went to for the prior exam. You can bring a sheet of paper with you, just like you could for the prior exam, and the rules are the same, right? You can put whatever you want on that sheet of paper, front, back, handwritten, typed. The biggest difference between the last exam and this exam, of course, is what's going to be on it, because last exam covered modules 1, 2, and 3. This exam is going to cover modules 4, 5, and 6. So module 4 covered APIs. This idea that if I tell you that something exists and give you some information about it, you can then take that and use it to perform some task in your code. The way that the utility we use to show that off is standard draw, right? So we used a drawing library to help make drawing things easier. We also talked about animations during that unit as well. The module that comes after that is module 5, which is methods. So knowing how to write a method definition, knowing how to call methods, and all the various parts of a method definition, like the return type and the parameters and all that fun stuff. And then module 6 was recursion. Recursion, which is really just an extension of methods in my mind, because recursion relies on methods in order to do its job. Recursion just being another way to perform repetition. So being sort of a replacement tool for loops, right? We can use recursion or loops to perform repetition, and the choice is going to depend on the problem we solve and things like that. Is there a question?
Yeah. For like the STV draw stuff, like to what extent of that would we be expected to provide, and like what would be provided like in the question?
Yeah, that's a great question. So the question's about standard draw. There is a lot of stuff that you can do with standard draw. We didn't even talk about all of it, right? And we wouldn't necessarily even have time to talk about all of it, even if I wanted to. So to kind of answer your question, you do not need to memorize the standard draw methods. You don't even need to put them on your sheet of paper. In fact, I would encourage you not to put standard draw methods on your sheet of paper, because if you need them on the exam, I will provide them to you. So I will give you, not the entire documentation, of course, because that would be way too much, but I will give you the documentation for any of the standard draw methods that you need, and expect that with that information you should be able to use them to solve whatever problem I'm asking you to solve. And if you think you need another method, you don't. I'm going to give you the documentation for all of the methods that you need to solve the problem. But yeah, good question. One other thing I wanted to mention that is kind of related to the exam, kind of not, is that this Wednesday, so our lab section's this Wednesday, there is no studio because it's an exam week. So we're not taking attendance on Wednesday. However, there is still an assignment due, right? Assignment 6 is due on Wednesday. So if you want to turn in your assignment, you can do that on Wednesday. The TAs will be in class on Wednesday to do assignment demos and answer questions about the upcoming exam on Thursday. You can also turn your assignments in early in office hours on Monday or Tuesday night if you would prefer to do that, and then use your time on Wednesday to do something else. That is totally fine with me. I don't have a problem with that whatsoever. Get your assignment in whatever way makes the most sense to you. And if you need help demoing or answering questions for the upcoming exam, the TAs will be in the labs on Wednesday, ready to answer your questions and help you out with whatever you need. I think that's it. Before we talk about some coding stuff, just want to pause one more time and see if anybody has questions about the logistics, what's coming up later on this week in terms of lab on Wednesday and the exam itself on Thursday. Does anybody have any questions about what's coming up later on this week? You all good? Awesome. Then I would like to remind you again that just like the last exam, I posted some study materials for you to use to help prepare. So there should be a couple links on Canvas down here. This is a big old giant quiz of past exam 2 questions, but this is going to be not coding questions, but fill in the blank multiple choice style questions. I'm happy to give you a little bit of a spoiler in that while there certainly will be multiple choice fill in the blank questions on this exam, probably fewer of them than there were on the last exam because we've done a lot more coding since then. So I think the most important thing you can do to study for this exam is take a look at the coding prep repository. That's where all of the past coding problems are for both code reading and code writing. I've actually already got this repository loaded up in Eclipse in the hopes that in just a moment you're going to ask me to go through some of these problems. These are some non-exam problems. So these weren't on past exams, but these are still coding problems that are relevant to the topics that are going to be on the exam. So if you're one of the questions I get asked most often is, where can I do more practice? Right here. There's tons of practice, so much practice right here of stuff that you can try out. Of course, students tend to focus on the questions that are only on the exam, which is fine. I don't mind that. But if you're looking for practice, if you're looking to learn, tons of other practice problems here for you to take a look at as well. So at this point in time, I would love for you all to suggest some problems for me to work on. I'm happy to work on any of these coding problems. I'm also happy to talk about any of the quiz questions, the multiple choice fill in the blank style stuff. Yeah, or if nobody suggests something, then I suppose I'll start picking stuff of my own. But yeah, go ahead. You got a problem for me, or yeah, go for it.
Please do the question 8 on the exam code writing.
Question 8 on exam code writing. All right, here we go. So for this problem, we want to construct a method named countValues that will count and return the number of times a particular value appears in the columns of a 2-dimensional array of integers. So here's an example given, which is almost always going to be the case. I think we're given this 2-dimensional array. It is 3 by 3, and we're looking for all of the times that 1 is going to appear. But we want to know per column. So if I look at this first column, I can see that the value 1 appears twice. So if I look at my result, I can see that it's a 1-dimensional array, 1 entry per column. And the first entry is 2 to indicate that there are 2 1s in that column. The second entry is 0 to indicate that the number 1 does not appear in this column at all, right? And then the third value is 1 to indicate that that value appears just once in that third column. So hopefully everybody understands what we're trying to do. Actually making it happen, of course, is a little bit of a different story. So if we take a look at what's provided to us, this is more like what you're going to expect to see on this exam, where a lot of times I will give you maybe this line of the method, or sometimes maybe what I'll do is I'll give you the method with the parentheses blank, and I might leave a blank here for the return type as well. So you may have to fill in the return type or the parameters, or I might give them to you. Those are both potential options. For this particular problem, they were given to you. So you didn't have to supply the return type, you didn't have to supply the parameters. You just need to solve the problem. So I think the first step is we gotta make this array. So task 1 is we gotta generate a new 1-dimensional array, and this is kind of a hint in that direction, right? Got to make a new 1-dimensional array so that we can start counting up the values in the columns. So I'm going to make that result array. And how big should it be? That's our first, I think, tricky question. This is kind of review of last section a little bit, right? I expect 1 entry for each column. So what I need to do is ask this array how many columns it has. Again, that's something that is a little bit of a review from last time, but the number of columns is given as a at 0 dot length. So if there are 3 columns in A, this array will have a length of 3. If there are 10 columns in A, then this will have a length of 10, and so on and so forth. Okay? We're now we need to count. We need to count how many times a certain value appears, which means we need to visit each element of this two-dimensional array and check it. I hope some alarm bells are going off in your head, right? If I need to visit each element in a two-dimensional array, what is the appropriate way to go about doing that? What do I need to start typing next? What structure am I looking for? Nested loops. Nested loops. Yeah, this is definitely a case where we need those nested loops. One for the rows and one for the columns. We're performing an array traversal, a 2D array traversal. We have to examine every single one of these values and see whether it's what we're looking for or not. So that requires us to do an array traversal, which is just going to be our standard double for loop. Some people like to name their variables row and column. That's fine. I used I and j. I mean, I is usually the column. I is usually the row, sorry, and j is usually the column. It doesn't really matter. Now that we have our nested for loop set up, we can ask our question. Does the value at position ij equal whatever value it is that we're hunting for? So this is the value that we're hunting for, this value that's been called find me. Okay, if the value at position ij is equal to the value that we're looking for, which is find me, then I need to somehow indicate that by adding 1 to the number of times that it appears in that column. So here's a question, taking a little bit step backwards. When I create this array, what's in it? What's going to be in this array right after I make it? What values? Zeros. They all start out at zeros. If this is true, I have found a value, and I need to bump up something by 1. Which position do I need to update? I guess is the tricky part of this. I found this position. This represents the number of times a value appears in each column. So I wish to visit the position that represents the current column that I'm on. Which value is that? What's the current column that I'm on? J. It is J. So I want to go to my results at position J, which is the current column that I'm on, and add 1 to that. So if it starts at 0, the first time it finds a value in column J, this becomes 1. And then the next time it finds a value in column J, it becomes 2, and so on and so forth. I think we're almost done. There's just one final step actually left. If this, what's this called again? What's this part of a method definition called? Return type. Return type. And it is not void, which means we have to return something. It is absolutely required for us to return something. There has to be a return statement in here. And that return statement in this case, I think, is going to come at the very end. Once I have finished my array traversal, once I've checked all of the values in my two-dimensional array, I expect my result array to be correct. So let's return our results. And this has already been set up for us to run the example, right? This is actually going to run the exact example that was given up above, along with a little loop here to display the results of our method calls. So if we run this code, hopefully we see 2, 0, 1, right? But don't just take my word for it. Like, try tweaking some of these values. What if I make the first column all 1s, right? Now, if I run it again, this should say 3, 0, 1 if it actually properly works, right? So if I run this again, it should say 3, 0, 1. And then that's still, I would argue, perhaps not good enough. You know, what if I add on another row? So now I've added on another row. And notice I snuck a 1 in there. So now this 0 should become a 1 as well after I add this additional row. And it does. So the method appears to be working. We would also want to perhaps add an additional column out here. And make sure that our code still works, even with that additional column added. So now, instead of seeing 3 entries get printed out, since there are 4 columns, I would expect to see 4 entries get printed out, and you can see that that last column has an entry of 2. That's how many times the value appears. And then finally, if I change this to something else entirely, right? What if I change this to 7? So now I'm not looking for 1s anymore. Now I'm looking for 7s. The first column has 0 7s. There's 1 7, 1 7, and 0 7s. So, okay, we try this again. 0 7s, 1 7, 1 7, and 0 7s. Yeah. So just to kind of reiterate, this is the way I would do it. This is the code that I would write. There probably are other ways to do it, but this definitely, I think, is the most direct approach. Does anybody have any questions about this? Yeah.
Would we expect it to be, well, I know we did like traversing one-dimensional arrays with recursion. Would we expect it to do like two-dimensional arrays with recursion?
The question was, would you be expected to do 2-dimensional arrays with recursion? I don't think I ever did an example of that in class. I mean, you know, can you use 2-dimensional arrays with recursion? Yes. But also notice that it very clearly says right here, it is not necessary to use recursion for this problem. And if that is the case, then I wouldn't even try. I think that loops are, I would think that most people would probably prefer to use loops over recursion. And that's actually one of the things that I commonly see on this exam in particular, is that people get their minds so caught up on recursion that they try to shove it into everything. Not everything. We covered 3 units, right? Recursion was 1/3 of that. So I'm not going to use recursion on every problem. I'm not going to expect you to use recursion on every problem. If you do not have to use recursion on a problem, then please do not. I think most times trying to use recursion on it would make it more complicated and make it harder for you. Question?
I'm a little confused on why you used like the column length for the value of like the array, and then why we did the J++.
Okay, so this is trying to count the number of times a value appears in the columns. So I'm going to have one value for each column in my 2-dimensional array. And so, you know, if there's 3 columns, then this is going to be 3 values long. If it's 4 columns, then it's going to be 4 values long, right? So that's why I created this array based on the number of columns. Does that help answer your...
Yeah, and then why do we do result like index J++?
Okay, so again, this represents the values in column 0. This represents the values in column 1. If I put I here, is I a column? No, I is a row. So J is the column that we're currently on. That's what we're counting. Yeah. Any other questions I can address about this problem? Yeah.
So for the test, it'll be pretty explicitly clear if we have to use recursion, or if we're just...
I often put it in bold. Yeah, I often put it in big bold letters. It says, you have to use recursion on this problem. Using a loop on this problem will result in no credit. And sometimes I even say the opposite. Sometimes I say, you have to use a loop on this problem. If you use recursion on this problem, that'll be 0 credit.
And if it doesn't say, it's fair.
And if it doesn't say, then you get to do whatever. Although, if it's not necessary, I try to say that too. If I say this, that means it's up to you, right? I'm not going to stop you from using recursion, I guess, if you really want to, but I'd say 99 times out of 100, that's going to make it harder, not easier. Yes?
How would you solve this problem using recursion?
How would you solve this problem using recursion?
Like, instead of using those 4 loops.
Well, so remember that recursion is used for repetition.
Yeah.
So I would need perhaps 2 forms of recursion, one for the rows and one for the columns, since I have 2 loops, one for the rows and one for the columns. I have to be honest with you, I don't know if I've ever tried to solve this problem recursively, and I wouldn't want to. I like this.
I see.
I don't think using recursion is an appropriate way of solving this problem.
Thank you.
Yep. Any other questions I can address on this question before we take a look at some other stuff? I think one other thing that could maybe help answer, you know, a lot of these questions, right? Especially now that you have the solution to this particular problem given to you. Run it through the debugger. Set a breakpoint. If you still don't understand how this solution is actually working, you know, you have the ability to step through this code, which is a fantastic way of understanding how things are going to work. So setting a breakpoint on the loops and then stepping through this line by line, you'll actually be able to see if my computer starts, there we go, just a little sleepy today. Here's everything starting out at 0, right? So I haven't found any values yet. And then I start checking values in my two-dimensional array, starting at I equals 0, j equals 0. So that's the top left corner, right? So I equals 0, j equals 0. Is that the value I'm looking for? No, it's not. Is the value next door a value I'm looking for? No. But eventually I'll find one. So no 7s in the whole entire first row, which is correct, I believe, because this is the array we're working on. There's no 7s in the second row either, so I'm going to go through this whole one, and still I haven't found any 7s. But I and j are chugging along, and then finally when I get to row number 2, I should finally find a 7. So at I equals 2, j equals 1. That's the first time that I have a 7. 0, 1, 2, 0, 1. So this is I equals 2, j equals 1. So that means it's going to go to the result at column 1 and add 1 to it to indicate that we have found that value. There's another 7 right next door. So as soon as we take a look at the next value at I equals 2, j equals 2, the same thing's going to happen. It's going to bump up that value to 1. And at this point we know we're done, but the code doesn't know that, so it's going to continue to check all of the remaining values. It's not going to find any more 7s. So, we'll finish it up. Here's the last row. Still no 7s, still no 7s. And now we're done. We've checked all of the values in the array, so the only thing left for us to do is say, here's your answer. I've looked at all the values in the array. Here are the number of times that the value appears in every column. All right, I'm not seeing any hands, so I hope that means there's no more questions about that problem. What are we doing next? Anybody have another one they'd like to see me do? Yeah?
Yes, can we go through the question 6, also the code writing of the exam?
Question 6.
Yes, this one involved the helper method, which I'm thinking.
Yeah. All right. This is a recursion problem. I think it says very much, well, honestly, the fact that it says to use a helper method should be a clue, but it does say we have to use recursion here. And I gave you a version that uses loops. So I think people get hung up on this problem a lot because the math is somewhat complicated, but I don't care if you understand the math or not. This is purely in my mind, this is purely a question of logic and flow. The math is not particularly relevant to me, right? So to consider what we're doing here, we want to take this code, which is doing repetition using a loop, and we want to create a recursive version. So we want to perform repetition using recursion instead. So let's talk about helper methods. What do I use helper methods for? There's 2 reasons why I might use helper methods. Anybody remember one of the 2 reasons why I use helper methods? Yeah.
You have an array that you don't want to mess with, but you need to manipulate it in some way, but you want to maintain its integrity.
So we did use arrays a lot, and I think that's a good point. We often did use helper methods with arrays. You'll notice that there's actually not an array here, though. So I would maybe tweak that explanation just a little bit and say that we use helper methods to include additional parameters, right? So we do that a lot with arrays, because with arrays we usually need an index. Usually the loop is what manages that index, I equals 0, I plus plus, that whole business. But with recursion, since we're not using loops, we don't often have access to that I value, so we have to use a parameter to represent it instead. That's what happened with a lot of the helper methods that we asked you to do in Studio and for the assignment. But there's no arrays here, right? So I want to make it clear that really the purpose of the helper method is to allow us to use additional parameters. And yes, arrays are a big reason as to why we want additional parameters, but any reason for having additional parameters is a good one. There's another reason why we use helper methods as well. Does anybody else remember what other reasons we use helper methods to do? What another reason is? Yeah. Yeah, or I would go a step farther and say repetitive stuff versus non-repetitive stuff. Yeah, but you're right. The helper method is the recursive one. It's doing the recursive stuff. The non-helper method is doing anything that doesn't need to be repeated. The same's true for loops. A lot of times we create variables before our loops, right? That stuff only needs to happen once, and then the repetitive stuff goes in the loop. It's the same idea. Did you have a question?
Do you think it's right to think about it like a nested recursion? Like how a recursion, like a non-recursive and
I don't know that there's any nesting going on. I don't think of it that way. I think of it as kind of like what I was just explaining, where you can see here that these values are created outside of the loop. These lines only need to run once. So those go in the non-helper method, whereas the recursion is going to do this stuff. So I'm not expecting this stuff to happen in the recursive method because it's not being repeated at all. I'm only expecting this stuff to kind of happen in the recursive method, right? Okay. So let's return to the task at hand, which is to start constructing the recursive algorithm here. If we want to take the square root of 5 using this method, right, it says the first thing that we need to do is actually create these variables. And so it also says you need a helper method. And you'll notice that these variables are referred to all throughout the math that's happening here. I'm not even going to talk about the math or how this works. It literally does not matter how this math works. To understand this problem. I could give you any math here, right, and ask you to do the same thing, and it would be a similar process. So all we really need to do is then recognize that, okay, this stuff's only happening once. So I should probably define these in my non-helper method, like so. And then the thing that we always do after that is we pass execution to the helper method. So we would say, you know, square root helper. Okay, but we have to decide, right, what this method is going to look like. What are the input parameters? What should its return type be? Those are all questions that we have to decide. And so consider that if I'm accessing these variables, right, inside of the repetitive stuff, that means that these variables are going to need to show up as parameters to my helper method so that the recursion is able to access them. It's a little bit differently than how a loop does it, because a loop is all in one place and it can see these variables. But within recursion, since I'm using different methods and different method calls, it's not going to be able to view these variables unless we pass them in as parameters. So I think what we're going to do is pass in x old, pass in x new. And with that in mind, we can kind of start to define the method itself. It's always going to start with the words public static. We're computing a square root here, so to me that implies that a double is going to be the return type, because I am computing square roots. So I do expect there to be some numeric result. And then I'll call this square root helper with double x old and double x new coming in as my parameters. And we're now ready to tackle the recursive part. The ending condition is actually already given to us right here. Remember that the way while loops work, as soon as this is false, we stop. Well, we want the same thing to be true with our recursive method, although a lot of times what ends up happening is we have to kind of phrase it a little bit opposite, right? So instead of saying, you know, while this is true, keep going, I'm going to actually do something a little bit different and say, like, if this is, notice I'm flipping the sign, if it is less than or equal to this value, then I'm done. Then I stop. I know what my answer is. My answer is going to be this. And consider what would happen, right? Just use some logic to say, all right, I create these variables. If this is false right away, right? If this is false right away, what is my answer? It's this, right? It's that. So same thing true for my recursive step. Otherwise, we have a bunch of math to do. Notice that inside of the loop, I'm redefining these variables, right? And then computing the next iteration of this. So I'm going to grab these two and paste them down here, and then do my recursive call. And we're almost done. There's actually just a few loose ends that need to be tied up here. One, there was a print statement here. I included that mostly to help you kind of trace this as you were going going through it. If you copy it down here, that's fine, but I didn't actually count off points for, not copying the print statement. It's not that big of a deal, the print statement to me. But what is important, notice that I made a mistake, somewhat of a mistake. I have this value called x that also needs to come in, and well, the original value of x comes in here, but I never pass it into the helper. Do you see that? But the helper needs it, so that tells me that, oh, I actually need 3 parameters, not just 2. I need x, x old, and x new. And then, believe it or not, we are so close to being done. You can see there's an error here. Does anybody know what the problem is? Why it's angry at me? Somebody help me out? I'm missing one word. Yeah.
That's missing the third parameter.
Oh, it is missing a third parameter. Yeah, I need to pass x in here as well. But it's still going to be angry at me. There we go. It's still angry at me. Does anybody know why? Still missing one word. I need a return. I need a return. Actually, I need a couple of returns. I need one here. And I also need one here. Okay. Don't just need to take my word for it. I've actually got, whoops, this should say square root r. So this is going to use the loop version, right? This is going to use the recursive version with my helper method, and the hope is that they'll give me the same answer, right? I get the same answer with a loop that I get with recursion, because again, loops and recursion are used to do the same thing, which is repetition. So if I run this code, I'm hoping that I see the same number pop out twice for the square root of 5. Oh, okay. So this is my loop version result, and this is my recursive result down here. This is actually from the print statement that's in the loop. I could actually take that out if I wanted to, just to clean things up a little bit. So the top one is using a loop. Bottom one is using recursion. You can see they're exactly the same. I actually wouldn't have been surprised if they were maybe even a tiny little bit different, but they are very, very, very close, exactly the same. Again, notice that you did not have to understand the math. I literally copied those lines of code. The takeaway here is not, do you know how to use the Babylonian method to compute square roots? That is not the goal of this problem. The goal of this problem is, can you take something that's written with a loop and convert it into something that uses recursion instead? Now, I know this was actually a hard problem. This is actually, I think, maybe one of the hardest problems that was given to you in this little code repo, so I'm not surprised that somebody asked me about it today. But this is still a skill that we talked about. I was here in class when we did recursion and showed an example in a loop and redid it using recursion. That is a good skill to know, and that is something that I could ask you to do on the exam. In hindsight, I probably would pick something that is not quite so mathematically complicated, because students get hung up on the math. But knowing how to convert stuff from loops to recursion, or the opposite, if I give you something with recursion and say write the same thing using loops, I think that's fair game. Any questions? Let me scroll down to my result here. This is my answer to this problem. Any questions on this problem before we take a look at some more coding problems? Not seeing any hands. Anybody have another problem they'd like to talk to me about? You already did one. Let me see if somebody else has one, and if not, I'll come back to you. Anybody else? What do you got?
It's kind of like a quicker question. For question 10.
The code writing question 10?
Yeah.
Uh-huh.
I was just a little confused on why the return type would be int.
Oh, it shouldn't be int. Actually, that's a mistake. That should be a string. So thanks for bringing that to my attention.
Okay.
We might as well do this one, though. I think while we're here, though, it says you may use either iteration or recursion. So again, I want to remind you that if you have the option, choose the one that's simplest to you. Right? There's no shame in that whatsoever. If I were solving this problem, I would use iteration. But I actually think that this one is simple enough that you could do it with recursion if you wanted to. So it might be a little interesting to see both solutions. The loop one is hopefully, I'm hoping that this is an easy problem if you use a loop. I mean, that this was meant to be on the easier side when I put this on the exam. We're going to plug n in here to my for loop, right? And then we'll create a string to store our result. It starts out as empty. There's nothing in it, right? Nothing's in that string yet. Or what some people did, which is also, I suppose, okay, except for there is one little wrinkle. They started out as, you know, the original word, and then say that this should be n-1, because this eliminates the need for one of the repetitions, right? If I started as the original word. The only problem that I have with that is that if this is 0, then technically this wouldn't work, right? So if n is 0, technically that wouldn't work. But the problem is a little bit ambiguous. Oh no, it does say positive. So actually that's not a problem. Yeah, not a problem at all. It does say positive. But yeah, I'm going to put it back just because I think, there we go. And then we would concatenate the text. You could use plus equals for this, or you could say it the long way, like that, and return your result. I think that's it. I think that's it for this one, if I'm using a loop. But let's try it out and see. Make sure we get... Uh-oh. Oh, well, turns out I screwed this problem up in a couple of ways, didn't I? I need to put a print statement in here, or it's not going to show us anything, is it? Need to edit this practice problem a little bit. But once I put in these print statements, we'll be able to verify that things are hopefully working correctly. All right, now hopefully I can see the results. There is, you know, hi repeated 5 times. There's bye repeated 3 times. So that appears to be working. I kind of would like to do this one recursively though, just to get a little more recursion practice and maybe compare and contrast a little bit. So if we redo this one, repeat, I usually just put a capital R on the end to indicate that it's the recursive one, not the loop version. We'll have the same values coming in. I don't think we need a helper method for this one, and I think that's another thing to keep in mind, right? Don't force yourself into a helper method if you don't need one. I think that overcomplicates things. I oftentimes will tell you if you need a helper method, so if I don't tell you that you need a helper method, you probably don't need one. That doesn't mean I'll count you off if you use one, but you're overcomplicating the problem, spending more time than you need to, perhaps, to solve the problem. So definitely be aware of that. Did you have a question?
Yes. So if the return type was like ends instead, you would use a helper first.
I mean, if the return type is int instead, then that would be a mistake, and instructions would be given to you during the exam or something like that to fix the mistake, to fix the discrepancy, because it clearly says up here that it... Oh, actually, it says it should print. It doesn't say it should return. It just says it should print. I overcomplicated this. I overcomplicated this problem. Wow. This can be done even easier. We actually don't need this at all. We actually don't need this at all. This could be, if I'm just printing, this could be void. I'm actually kind of glad I made this mistake, to be honest with you, because this is a common mistake that students will make on this exam as well. Returning and printing are not the same thing. Returning and printing are not the same thing. People get them confused all the time. People think maybe they're the same thing, or they use one when they mean the other, right? Printing is the act of displaying text on the screen. That text does not go anywhere besides on the screen when I print it. Returning is the act of moving information from one part of my code to another part of my code. So the act of returning is moving data around, actually passing values from here to over here. Whereas printing just says, show this on the screen. Returning does not show anything on the screen. The act of returning by itself shows nothing on the screen. I don't actually see those return values unless I print them out. So I actually overcomplicated this problem. This even simpler solution is good enough for the non-recursive version of this problem, and I can probably actually don't need these print statements. There we go. And for the recursive version, we're just going to keep going until I run out of repetitions, right? So if n is 0, do nothing. Or I might rephrase this a little bit because while it's not technically wrong to have an empty set of brackets like this, I think it looks sloppy. It's not a good idea, I think, to leave these empty brackets. So what I might say instead is if n is equal to 1, then print out the text the last time, and you're done. Otherwise, this is where we'll do some recursion. We'll say, well, okay, you still have to print out your text. But then once you're done with that, you're going to repeat the text one fewer time. And this, like above, should be void, not string. So here's the recursive way to do this. Notice there's no helper method involved. You could actually probably simplify this even a little bit more if you wanted to. But let's check and make sure this works before I go messing with it anymore. If I switch these to call my my recursive version. Uh-oh. Come here. Ah, shoot. So kind of, right? Kind of, but okay. This one shouldn't have the ln on it, right? Because there's more to come. There's more to go. Whereas this one, since I know it is the very last one, I know I've hit the base case, and therefore this is the last one. That's okay to have the print ln on it, right? Because it's the very last one of the line. Let's try that again with that little tweak. There we go. There we go. These are now identical. These are now identical. I think that this and this are doing exactly the same thing. One is using a loop to perform the repetition, and this one is using recursion to perform the repetition. Yes?
Could you explain how when you return in the else statement, how you like edit the parameters?
Edit the parameters?
By doing like the n-1.
Okay, so yeah, let's talk about that. In order for a method to be recursive, the bare minimum definition of recursion is that a method must call itself. So if the name of the method is this, that means that I expect to see the name of the method appear somewhere inside of the method, right? That's what it means to call the method. So with just that method call, if all this method said was this, it would actually still be recursive. But the problem is that just like we have for loops, we want to ensure that the repetition is eventually going to stop. The repetition, we usually don't want it to go on forever. We don't want it to go on infinitely. So that's why a good recursive method requires a base case. Base cases aren't required to do recursion, but they are required if you want your recursion to stop and not run forever, which we almost always do, right? So then that means that, okay, I've decided I'm going to stop. This must progress me towards that stopping point. Just like within a while loop or a for loop, right? Every time I go through the repetition, I am one step closer to the end of that repetition, to the end of that loop, right? So the same idea exists here. Every trip through this recursive method is like taking one trip through a loop. So the next time I take the trip through this method, I want to make sure I am one step closer to being at my base case. And so if I just plug in n by itself without modifying it, right, think about what that would lead to. If I plug in 5, then it's going to get down here because it's not equal to 1, and it's going to try 5 again, which is not equal to 1, and then it's going to try 5 again, and then it's not equal to 1, and it's going to try 5 again, forever, infinitely. If I subtract 1, in fact, might even prefer to do this in the debugger just to show you, since I am a big fan of using the debugger to help understand how pieces of code work. So we can see that the first time, where am I actually? Oh, I ran the last program by mistake, I guess. Oh no, here I am. There we go, perfect. So here I am the very first time for n is equal to 5, so 5 is not equal to 1. I jump down to my recursive step, which says print this out and then do some recursion. But I'm not going to run it for n is equal to 5. I'm going to run it for n is equal to 4. I'm going to get one step closer to 1. Right? So still haven't hit the base case yet, but n is now 4. And notice over here too. What's this called on the left-hand side? What's this that I'm looking at that has all these methods on top of each other? Starts with an S? It's a stack. It's a stack. So it's showing me, what does a stack do? A stack shows me what methods have been called and the order that they have been called in. And if I'm doing recursion, I expect to see that same method show up over and over and over again, because that's what recursion is, a method calling itself over and over and over again to perform repetition. Whoops, I hit the wrong button there, sorry. Let me do it over again. Hit the wrong button. All right, so here we are in the first trip through. We hit our recursive step. Here we are in the second trip through. Here we are in the third trip through. Notice that n is going down by 1 each time, right? Oops, wrong button again, but this time I can save it. Here we are on our fourth trip through. You can see the stack is getting bigger as well. N is equal to 2. And now finally, n is equal to 1. So we've hit our base case. Our base case says print this out, and there's no more recursion, right? No recursive call here. But notice that the stack still has all of these methods. We have to work our way back. We always have to travel all the way back, retrace our steps back through. We actually have a name for this. It's called backtracking, right? Backtrack through all of the methods that were called until we get our answer back out, which in this particular case, there's nothing for us to do. So you can see that it did it all very quickly. That's not always going to be true. Sometimes there's going to be more code here, right? In which case you have more work to do. In this particular case, that wasn't true, though. All right, any questions about this problem before we take a peek at another one? Yeah?
For the recursive way to do it, could you just say, like, if n is greater than 0, and like how would you have in the else statement?
Probably. The only tricky part is the fact that one of these is print line and one of them is print. So I was kind of on the same page as you before, where do I even need to have an if-else, or could I just do this all as an if statement? It may still be possible to do, but if we're trying to make the output look like this, I do have to use a print here and a println when I hit the base case.
Okay, I was just wondering because, like, in the instructions, it doesn't say that, like, it would have to, like, have a line break between them. It just says, like...
You're right. Yeah, and on an exam, I don't know that I would be that nitpicky anyhow, to be honest with you. Yeah. Yep. Any other questions on this problem before we take a look at another one? Any questions? Does anybody have another problem they want me to work through? Yeah, in the back. Code reading, question 5. Okay. So this one's just asking what the output is of the following method calls here, right? Sometimes it will be just simple and straightforward like this. Other times I may ask you to do something that's called the substitution method, and I think you could actually use the substitution method to solve this problem to a degree as well, but I'm trying to debate whether I should do that or not. Let's just try and solve it straight up, and then I can talk about the substitution method a little bit more afterwards if I need to. So, all right, we have this method. I see it takes in 2 values. It looks like they're integer values, 2 and 0. And so the first time through, I see that right away we're going to print out x. So the very first thing I expect to see is the number 2, because that's the value that was plugged in for x. All right. If y is greater than 3, which it is not, y is 0. Else, if x is greater than 0, which it is, x is 2, it's now saying that we're going to do the same thing except for x minus 2. So that should get me 0 here. Y remains untouched. So I am now doing m2 of 0, 0. That's the next thing that I need to take a look at, right? This is recursive, doing recursion here. So, all right, m2 of 0, 0 says to do what? First, I'm going to print out x. So x is 0. There it is. I'm going to print out x. It's going to ask if y is greater than 3. It's not. It's going to ask if x is greater than 0. It's not, right? So I'm going to print out x, right? Again, a second time. But then remember that I didn't start here. I actually started here. And this call is not done yet. It's waiting, right? It got to this point. But as soon as this is done, as soon as it figures out, what this is, it's going to return here and then try to finish the rest of the method, which says to print out x again. Or here's another way to think about this. Every time this method is called, I know the value of x is going to get printed out twice, once at the beginning and once at the end. So if I call this method twice, I know that I'm going to have 4 values get printed out, 2 for each method call. The value of x has not changed, right? So the first value of x was 2, and that's what I expect this value to be. But let's run it and see if that in fact is what we get for our first answer. There it is. X is 2, 0, 0, 2. Once again, though, let's run this through the debugger. I know there's another one down here as well that we can take a look at in just a second, but let's run this through the debugger and make sure that you understand how the progression works, because this is one of the trickier parts about recursion, remembering that you have to go back, right? You drill down to the base case, but just because you hit the base case does not mean you are done. You still have to return all the way back to the original call and resolve any additional work that might need to be done on the way back up. So let me show you what I mean by that. I step in here. Here I am. X is 2, y is 0. That's exactly what it says, right? 2, y is 0. First if statement is false. The second if statement is true. So I see that I need to do some recursion here. I also have already printed out the first 2. So there's the first 2 that got printed out. I step into here next. Now notice what the value of x is. So it prints out the value of x now, which is 0. Y is not greater than 3, so that's false. X is not greater than 0, so that's also false. So here I am now on the very next line, where I'm going to print out x again. It's still 0. That has not changed. The value of x has not changed at all. So there goes 0. But pay attention over here. This version of M2 is not done yet. Remember, it got down this far, and then it did another call. So it's actually waiting for this call to be over, which it is now. This method call is now over, but I have to return back here and finish up any work that might be done. And once I do that, notice that, okay, it returned back here and then kept going because there's still another line of code after that if statement that needs to be executed. But since I'm in the original version, my value of x is not 0, but it is now 2. Just like it was originally, and there is where the 2 gets printed out for the second time. I hope that illustrated the path through this code. This is going to be, kind of a similar one. Instead of working it out, I may just use the debugger to help me step through this one instead. I'm looking for values of y that are greater than 3, and I've got one. So I print out my value of x, which is 2. My value of y is greater than 3, so that says that I'm going to do actually this version of recursion, where now I should have 2, 3, right? 2, 3. So here we are again. I print out x. That's going to be 2. So I have 2 2s in a row. I'm not greater than 3 anymore, but x is greater than 0. So it is going to hit this recursive version now. And now I'm at x equals 0, y equals 3. Okay, so we kind of know how things are going to go from here because this is similar to where we ended up before. But how many method calls do we have this time? 1, 2, 3. That means that 6 values are going to get printed. But I already kind of know what it's going to look like. This is my first value from the first method call. This is the value from the second method call. Here comes the 0. False, false, another 0. But then we have to go back. We still have to revisit each of the method calls and see if there's more work to do. I'm going to print out 2. And then I'm actually going to print out 2 one final time. So the answer to the second part of this is 220022. So 2002 is that one, and 220022 is that one. But in order to solve these kinds of problems, you really have to understand the flow of execution. And that's honestly one of the biggest things that I'm going to try and test you on Thursday, because that's one of the most important parts of the material that we covered. Do you understand how method calls affect the flow of execution? Do you know what line to go to next? Because there's always one correct answer of what line to do next. Yes?
Can you explain why you got the last 2s?
These last 2s?
Yeah.
Okay. Yes, I can. Let me start this over in the debugger again, because I think that's important to illustrate where those come from. So here I am. I'm about to run this line, right? The bigger one. I step in. Notice that x is 2. There are 2 print signs here, right? Print, I'm going to print x at the very beginning. I'm going to print 2 at the very end. But what happens in between? In between, it tells me that I have to go do something else first. So notice that I've only printed out the first one. I have not done this one yet. I haven't done it yet. It's now saying, well, you have to go do this. So I'm not going to keep going. I'm going to do this. I'm going to do this. So, okay. If I go into this method call, it's going to say the same thing. I am going to have to print out the value of 2 twice, once at the beginning and once at the end. But what am I being asked to do in between? Well, now it's saying that I have to do this in between. Okay. So when I get here, I can see, all right, I have to print out 0 twice, but notice these other 2 are still here waiting. They're still here waiting for the stuff to finish up. I'm not going to go back to this one until this one is done. And I'm not going to go back to this one until this one is done. That's how method calls work, right? The method call says, go to this method and do everything until it's done. And then come back here and keep going. So these 2 methods, you can actually see what lines they're waiting on if you click them, right? The first one is waiting here. It's waiting. It's waiting, it's waiting, it's waiting. Whenever it eventually is done doing this, I'm going to come back, and then I need to do this last one. So if we return to the case where x is equal to 0 and y is equal to 3, this is going to hit the quote-unquote base case. It's going to print out 0 twice. I'm not doing any recursion. I'm done now. But I still have to revisit each of these 2 and finish up the 2. That's from one of the methods, and then the other 2 is from the other one. So that's where those last 2s come from. So now you can see the stack has shrunk by 1, and I'll print out this 2. And then finally the stack has shrunk 1 more, and I'll print out the final 2. Hope that helps answer your question. It's actually a great lead into, I think, what I want to do, which is probably the last problem that we'll get to today, since we're kind of running out of time. Let's talk about the substitution method, because this almost certainly will be on the exam. I could have used the substitution method to help me solve that last problem, and actually I don't think it would have been a bad idea for me to do that. But let's talk exactly about what the substitution method is, in case you are asked to do it, which, spoiler alert, you probably will be asked to do the substitution method. It's literally just me pretending to be the debugger. Like, that is quite literally what I view the substitution method as is just me pretending to be the debugger. Here's how I would solve this problem using the substitution method. I'm going to start by writing out the very first thing that I've been given. So, okay, f of 3 is what I'm being given. F of 3 is equal to what? Well, let's step through the program and figure out. If this is 3, then I'm not here. That's going to be false. This is checking if n is even. It's not. It's 3. So I'm here, right? This is where I must be if n is equal to 3. So, all right, that is equal to this guy. F of 3 times 3 is 9, plus 1 will be 10. Everybody see how I got that? So f of 3 gives me f of 10, right? But now I have to figure out what f of 10 is. What is f of 10? F of 10, if I plug 10 in, it's not 1. It is even, so that's good. This is going to give me, this is going to say, all right, f of 10 divided by 2 is 5. So that's going to say f of 5. But what is f of 5? We have to figure that out now. If I plug 5 in, it's still not 1. Still not even. Well, 5 is not even. So I'm going to come down here. And now I see, okay, 3 times 5 gives me 15, plus 1 gives me 16. So I'm going to do f of 16 next. What is f of 16? 16 is even. So I'm going to do f of 16 over 2, which is f of 8. What is f of 8? 8 is even. So it's going to give me the f of n over 2, which is 4. 4 is even. So it's going to give me f of n over 2, which is 2. 2 is even. So it's going to give me f of 2 over 2, which is 1. And hallelujah, finally, I hit the case where n is equal to 1, and it says, all right, that is 1. F of 1 is 1. But we're not done yet. This is actually the same thing that I've kind of been preaching with the last recursive problems. I've hit the base case. This is my base case, but I'm not done yet. The substitution gets its name from the fact that now that I've determined what this is, I can take this value and I can substitute it in here. So in order to write this out properly, I would say that the f of 2 is equal to 1. And now that I know what the f of 2 is equal to, I can say that the f of 4 is equal to f of 2, which is equal to 1. And this one is, I don't know if I picked the necessarily best example to run through here, since the answer is just going to be 1s all the way up. If I have time, maybe I'll do a second one, just to do one that's a little bit more interesting than this. Although I will say that even if you determine the answer is 1, to get full credit on this, I need to see all of these recursive calls, right? I want to see the whole path. So even if you determine very quickly that, oh yeah, the answer is always going to be 1, well, that's only going to get you a little bit of the credit. I really need to see the full path. And this, while this is kind of a simple back half of this substitution method, it won't always be that simple. I want to kind of try and see if maybe I can find another one to look at that illustrates that point. Here we go. Yeah, this is a better one. I should have done this one first. Let's do this one. This is question number 12 in the code reading if you're following along with me. So it says to start out at foo of 3, which is equal to, all right, so this is coming in as 3. That's not 0. It is greater than 0, so it's going to be 2 times foo of negative 3. Okay, 2 times foo negative 3. So what is the foo of negative 3 then? Foo of negative 3 is going to be, it's not greater than 0, so we're going to come down here, right? It's going to be foo of negative 2 plus 1. And then, oops, so what is the foo of negative 2? Well, still not greater than 0, so it's going to be this of negative 1 plus 1. right? What's the foo of -1? That's going to be equal to the foo of 0 plus 1. And now, this is our base case. Foo of 0 is our base case. It says return 1. So this is equal to 1. This is going to have a little bit more substitution going on, because you can see that aside from just the recursive calls, there's actually little bits of arithmetic here that you're going to be expected to perform as well. So be very careful. I think doing this substitution properly is important, right? The foo of -1, after I substitute this value in for here, is going to be equal to 1 plus 1, which is equal to 2. So that means that the foo of -2 is going to be equal to 3, right? 2 plus 1. Foo of -3 is going to be equal to 4, which is 3 plus 1. And then this last one, notice that I'm not adding 1, I'm actually multiplying by 2. So the foo of 3 is going to be 4 times 2, which gets me 8. Notice that most of the arithmetic didn't happen on the way down to the base case. It happened on the way back up from the base case, right? That's why doing the substitution method is important. If you don't, believe me that this is the outcome, you can also, run it for yourself and print out the result of this, or run it through the debugger. I think that's also another great way to verify these results. But there's my 8, right? There's my 8. So substitution method is a great way to work out the results to recursive problems. Any questions about this problem or the substitution method or anything along those lines? We have 13 minutes left. I could do maybe one more quick one if anybody's got a quick one for me to do. If anybody has a suggestion they'd like to see me do. If not, I might just go ahead and wrap it up and call it a day. Yeah, question?
Could you go over the last code writing one?
The last code writing one. Let's see what this one is. Okay. Yeah, okay, great. I'm glad you asked me to do this one. I hope I have enough time to do this one. I will get as far as I can in the 13 minutes that I have to work through this one. Also, too, I guess while I'm thinking of it, there is another section after this. I'm running a whole another review session. So if you, I might do exactly the same problems. It's kind of up to them, right? But if you want to stick around and ask me to do different problems, next section you are more than welcome to stick around and do more exam review if that would be helpful to you. But for this problem, you're given an image, and here we go. So we're doing standard draw. I believe the problem gave you. On this problem, I would have given you to kind of reference the question that was given to us before. I would have given you the documentation. I would have given you an explanation about the square and the circle methods, because that's what you need, right? And that's really all you need from standard draw to do this problem, are the ability to draw a square and the ability to draw a circle. When doing these kinds of drawing problems, if they are recursive, a lot of times they're going to be divide and conquer problems. And this is an example of that. I can see this pattern is going off in two different directions. It looks like this big square. So it's almost always going to go from the bigger shapes to the smaller shapes. So this big square I can see then splits off into two smaller, actually this square and this square are the two smaller ones, and then each of those squares has two smaller ones coming off of it. So the directions that I'm moving in are diagonally up and to the left and diagonally down and to the right. So I would expect to see two recursive calls, one that says keep going up to the left and one that says keep going down to the right. This is very similar to the circles upon circles problem that you may have seen in Studio, that I hope you saw in Studio, with a little tweak to it to indicate that you got to switch shapes on the way down. So the base case is almost always, for drawing problems, the base case is going to be almost always going to be, if the size is super small, so if the size is less than 0.01, then stop. it's too small for me to see the drawing anyway. Yeah, question.
Just like on this stuff, if we were to get this on the test,
Uh-huh.
would you grade based upon like, for that image, it scales down by a certain degree each time that you don't like theoretically know.
Sure, yeah.
Would you be lenient on that grading?
Absolutely, yeah. I'm not looking for you to get the exact ratio right. I'm looking for the recursive structure to be right. I think that's a great question. Yeah, thank you. For some of these drawing problems, I actually might prefer to phrase it the opposite way. Instead of saying, if the size is too small, then stop, I might say it the opposite. I might say, if the size is big enough, then keep going. But it's kind of up to you. The problem says that, it doesn't actually give much about the sizes of the shapes. That's okay. I can tell from looking at the image, right, that the squares are bigger than all the circles. So somewhere it switches from drawing squares to drawing circles. It seems like at some arbitrary point it says, I'm not going to draw squares anymore, I'm going to draw circles. So I think that's the first thing that needs to happen, is decide whether I'm drawing a square or whether I'm drawing a circle. So, if, I know this looks somewhat repetitive, but I'm saying, if the size is greater than 0.25, then I'm going to draw a square. Not a filled square, but just a regular square, using the given values. Otherwise, I'm going to draw a circle. And I'll just use the size for the radius instead. And then down here, we're going to have our two recursive calls, one for up left and one for up right. Or I'm sorry, down right. And it's up to us then to just figure out how to fill in these parameters. So if I am, if I'm starting at this big square and I want to go diagonally up left here, I can see that the center point, to get from the center point of this square to the center point of this square, I'm just adding the size, right? Or actually, I'm subtracting the size from the x-coordinate, and I'm adding the size to the y-coordinate. So if I go back to my code, I would say that I'm going to take the same center point but subtract the size from it to go to the left direction, and I'm going to take the same y-coordinate and add the size to it, because that is going to make me go up. The size itself is going down. I'm going to guess that it's being divided in half. Actually, you can kind of tell from the picture that it is in fact being divided in half. But again, I'm loosey-goosey about that. If you said over 3 or something instead, that would probably be okay. And then for going down and to the right, it's going to be similar story, but opposite. I'm going to the right, so I need to add the size, and I'm going down, so I need to subtract the size from my y-coordinate, but the size itself is still shrinking by a ratio of 2. And let's see how close we got here. This may not be exactly right, but I hope it's somewhere in the right. Whoops. Close. I think this is I don't know what this number is supposed to be. I'm a little bit disappointed. I think on the problem when this was on the exam, I told you what this value is, so I'm a little surprised not to see that number given to you. That's kind of my bad, to be honest with you. But let's see if I can get something somewhat approximate. All right, I'm in the right ballpark. You can see that I'm getting kind of close to the given image. I think with a little bit more tweaking here, I could get it looking pretty good. But again, the goal is not to necessarily, I went too far down for my base case this time, but this is interesting to watch perhaps. The goal is not to necessarily get the image nailed exactly. On this problem, what I'm looking for far more than does the image match exactly is, do they understand the structure? Do they understand that a divide and conquer problem requires multiple recursive calls, right, going in all of the various directions, just like max path length did on the assignment. Maybe that's a spoiler, I don't know, but hopefully not too much of one, right? Divide and conquer problems are going to require multiple recursive calls, one for each direction of travel, basically. And so we can see here that this is actually pretty close. I think it's not exactly the same, but close enough to satisfy me. It looks like the squares went down one more level. But we're in the right ballpark. Definitely in the right ballpark. I think if this number was tweaked a little bit more, so like 0.2 or something, I don't know. I don't need to sit here and figure it out all day. Any questions? We've got just a few minutes left, but I'm happy to try and take any last questions. If not, we'll go ahead and call it a day. If you have any quick questions, I'm happy to stick around after class. And as I said, you're welcome to stick around and do more review if you would like to. Otherwise, I will see you either Wednesday in the labs or Thursday at the exam. Hey. Yeah, give me just